Find dy by dx if e to the x plus y minus e to the x minus y is equal to 1. So we'll just write that out to begin with. Now, the problem is we've got e to two different functions, a function of x, a function of y. But if we use what's known as implicit differentiation, and we're going to differentiate everything with respect to x, but we'll notice that if we were to do d dx of e to some function of x, then you differentiate that function and then write down the same function again. So get f dash x e to the fx. So what you're going to do is apply it to this. So you're going to differentiate x, you're going to get 1. If you differentiate y with respect to x, you get dy by dx. So we end up with 1 plus dy by dx times itself. So we've sort of applied this here. And then exactly the same thing here, but we've got a minus sign. So it will be 1 minus dy by dx e to the x minus y. And if we differentiate 1, we just get 0. Right, that's the difficult bit done. Now it just now becomes a bit of an algebra problem. So expanding the bracket, we're going to get e to the x plus y, 1 times that, e to the x plus y times dy by dx. Now be careful here, we've got a minus sign, so we've got minus 1 e to the x minus y, so we get minus e to the x minus y, and a minus minus will make a plus e to the x minus y dy by dx. Be careful here, minus minus makes a plus, and you've still got it equal to 0. We're going to collect everything with dy by dx on one side, so we've got e to the x plus y dy by dx plus e to the x minus y dy by dx, and then on the other side we're going to get e to the x minus y because it's minus, and this one will be minus e to the x plus y. So writing that out again. Okay, so now have a common factor on the left-hand side of dy by dx. We'll write that out. So we've got e to the x plus y plus e to the x minus y dy by dx. And then we'll keep the right-hand side the same. So we'll take this side and we'll now divide it by this side. And then you're going to get e to the x minus y, e to the x plus y, e to the x plus y over e to the x plus y plus e to the x minus y. And now we're going to apply some rules of indices. So we should know these. A to the m minus m is a to the m divided by n to the n, and a to the m plus n is a to the m times a to the m. So applying this to these, you're going to get dy by dx is going to be e to the x over e to the y minus e to the x times e to the y. And then we're going to have over here e to the x, e to the y over e to the y, e to the x over e to the y. Now we've got here e to the y, e to the y. So what we're going to do is we're going to make a common denominator for the numerator. So we're going to e to the x. Now e to the x, and when you multiply e to the y times e to the y, you're going to get e to the y times 2, so it's e to the 2y, another rule of indices. And similarly at the bottom, you're going to get, in the denominator, you're going to get e to the x, e to the 2y, plus e to the x, and again that will all now be over e to the y. So if we do keep, change, flip, okay, so this one becomes the same, you're dividing, so you flip, the e to the y's will cancel out. So you end up with e to the x minus e to the x, e to the 2y, over e to the x, e to the 2y, plus e to the x. Now, we can now factorize e to the x out of the numerator and the denominator. So we're going to have dy by dx is going to be equal to e to the x. When you take e to the x here, you're going to get 1 minus e to the 2y. And here you're going to get a similar sort of thing. E to the x will come out. You're going to get e to the 2y plus 1. E to the x divided by e to the x will cancel out. And you'll be left with the final answer of 1 minus e to the 2y over e to the 2y plus 1. Okay, so this has been a video to show you how to do implicit differentiation with exponentials. I hope you understood it, and thank you very much for watching. And I maybe ask you to consider subscribing to my channel, where you will find thousands of maths videos which I've been making over the last 10 years. And then also in the notes of this video will be the link to my video site, where you could probably watch the videos by topic, all the way from Key Stage 3 to A-Level Further Maths. Okay, I hope you enjoyed this video. Thank you very much.